What's up guys, this is Massey. Welcome to another video. In this video I want to show you what are the equations of line in 2 space and 3 space. So vector equation of a line in 2 space can be written as r equals to r naught plus t times m, which means that xy equals to x naught y naught plus t times m1 m2. So this is called vector equation when we write it as x and y equals to x naught y naught, which is the point, plus t times m1 m2. We call it a vector equation, and m1 m2 is the slope. The first example, it says write a vector equation for the line through the points a 1 4 and b 3 1. So we need to write down the vector equation first. We can say AB will be 3 minus 1 and 1 minus 4. So it's going to be 2 and negative 3. That's going to give us the slope because it's going from A to B. So 3 minus 1 is 2 and 1 minus 4 is negative 3. This is the slope. So when we want to write down the vector equation, we can say any of these 2 points, doesn't matter which one you select, let's say the first one, plus t times 2 and negative 3. This is called vector equation. I could also write it in terms of 3 and 1 plus t times 2 and negative 3. Both of them are correct. Now it says determine 3 more position vectors to points on the line. So if we consider the first one an equation, say we call it t equals to 1, t equals to negative 1, t equals to positive 2. So therefore the first one is going to be 1 and 4 plus 2 and negative 3 will be 3 and 1. Then we have 1 and 4, negative 2 and negative 3. So 1 minus 2 is negative 1, 4 minus negative 3 is going to be 7. Then we have 1 and 4 plus 2 times 2 and negative 3. That will be 1 plus 4 is 5. 4 minus 6 is negative 2. So it's going to be 3 more position vectors. Now the last part, it says determine if the point 2 and 3 is on the line 2 and 3. So we can say 2 and 3 is on 1 and 4 plus t 2 and negative. This is the vector equation that we found it in here. So if I got the same t for x and y, it means that yes, 2 and 3 is on the line. If these two t's is not correct, they're the same, it means that 2 and 3 is not on the line. So I can say 2 equals to 1 plus 2t and 3 equals to 4 minus 3t. So that will be 1 equals to 2t, t is 1 over 2. And here we have 4 goes to the other side, negative 1, negative 3t. So t equals to negative 1 over negative 3 or 1 over 3. Since they are not correct, we can say 2 and 3 is not on the line. Now we have also a parametric equation of line that we write it in this form: x equals to x naught plus t times m1, y equals to y naught plus t times m2. So let's see, consider line L1, which is x equals to 3 plus 2t and y equals to negative 5 plus 14. First of all, find out the coordinates of 2 points on this line. So again, if t is 1, x can be 3 plus 2 times 1, y is negative 5 plus 4 times 1. That's going to be 3 plus 2, 5, negative 5 plus 1 is negative 1. So it's going to be 5 and negative 1. If t is 2, we can say x is 3 plus 2 times 2, y is negative 5 plus 4 times 2. It's going to be 3 plus 4, 7, negative 5 plus 8, that's going to be 3. So you have 7 and 3. it says in part B, write the vector equation of this line. Here we have it in terms of parametric form. If I want to write it in terms of vector form, it's going to be 3 and negative 5 plus t times 2 and 4. Then write the scalar equation of this line. How to write the scalar form? We have x equals to 3 plus 2t, y equals to negative 5 plus 4t. It means that t equals to x minus 3 divided by 2 and t equals to y plus 5 divided by 4. So t's are equal, so we can say x minus 3 divided by 2 equals to y plus 5 times 4. So I multiply both sides by 4, then it will be x minus 3, y plus 5. You have 2x minus 6, y plus 5, goes to the other side, 2x minus y minus 6 minus 5 equals to 0, or you can say 2x minus y minus 11 equals to 0. That's the scalar equation, as you see it here. Then in part D, it says determine if the line L1 is parallel to the line L2, which is x equals to 1 plus 3t, y equals to 8 plus 12t. So the slope of L1 is 2 and 4. The slope of L2 is 3 and 12. Here we have 3 over 2, and here we have 12 over 4. This one is 3, this one is 1.5. These are not the same. The ratio is not the same for x and y. It means that they are not parallel. Because if they are parallel, the slope of one line has to be the multiple of the slope of the other line. In this example, it says consider the line with scalar equation 4x plus 5y plus 20 equals to 0. It says determine the position vector that is perpendicular to this line. Perpendicular to this line. First of all, whenever we have equation in terms of scalar equation, the normal vector is going to be AB. It means that AB is perpendicular to the line. So for this example, 4 and 5 is perpendicular to the line. And it says write a vector equation of the line. So we have 4x plus 5y plus 20 equals to 0. Let's find out 2 points on it. If we have x equals to 0, we have 5y plus 20 equals to 0. So y will be negative 4. So we have 0 and negative 4. If y is 0, we have 4x plus 20 equals to 0. So x equals to negative 5. So it's going to be negative 5 and 0. So the slope is going to be so I forgot to record it, this part. So whenever you have this scalar form, which is 4x plus 5y plus 20 equals to 0, if you want to find out the position vector perpendicular to the line, we can say that in scalar equation, whenever we have ax plus by plus c, the vector a and b is perpendicular to the line, which is called normal vector. Which in this case is going to be 4 and 5. Part B, it says write a vector equation of the line, which is going to be x equals to 0. We need to find out the 2 points first. 0, 5y plus 20 equals to negative 4, 0 and negative 4. And whenever y is 0, when you sub it there, x equals to negative 5. So it's going to be negative 5 and 0. So m will be negative 5 minus 0, which is negative 5. 0 minus negative 4 is going to be 4. So that's the slope. It's going to be negative 5 and 4 t plus any point, which can be 0, negative 4, or negative 5 and 0. So any of this equation is going to be acceptable, and both of them are vector equation. So as we saw here, a normal vector to the line L is a vector n, which is called normal, that is perpendicular to the line. If L is ax plus by plus c equals to 0, then n is ab. Vector equation is r equals to r naught plus t times m. If we consider in 3 space, we have x, y, z equals to x naught, y naught, and z naught plus t times m1, m2, m3. This is called vector equation. If you want to write it in terms of parametric equation, x will be x naught plus tm1, y equals to y naught plus tm2, z equals to z naught plus 3tm3. So a line passes through points 2, negative 1, and 5, and b, 3, 6, and negative 4. Write a vector equation of the line, which is going to be x, y, 0, z equals to any of these 2 points, 2, negative 1, and 5, plus t times m. m1 is 3 minus 2, which is 1. 6 minus negative 1 is going to be 7. Negative 4 minus 5 is going to be negative 9. We can write it like that. If we want to write in terms of parametric equation, we can say x equals to 2 plus 1t, or t, y equals to negative 1 plus 7t, and z equals to 5 plus or minus 9t. That's going to be the equations. And the last part, it says determine if points C, 0, negative 15, and 9 lies on the line. So we have 0 equals to 2 plus t, negative 15 equals to negative 1 plus 7t, 9 equals to 5 minus 9t. So t equals to negative 2, and here we have t equals to negative 2, and here we have 9 minus 5 is 4. T will be negative 4 over 9. As you see here, all of them must be the same, but since only 2 of them are the same, it means that this point, 0, negative 15, and 9, doesn't lie on this line. It does not. Next one, it says write a vector equation for a line given each direction vector m and point p. It is very simple. You're going to say x and y equals to 2 and 7 plus t times 3, 1. And here we have x and y, 10 and negative 4 plus t times negative 2 and 5. Then we have x, y, z equals to 9, negative 8, 1 plus t, 10 minus 3, 2. X, y, z equals to negative 7, 1, and 5 plus t times 0, 6, and negative 1. This example, it says write a vector equation of the line through each pair of points. So we are dealing with 2 points. We need to find out the slope first. It's going to be 4 minus 1, 3, 10 minus 7, 3 as well. So we can say that's going to be x, y equals to 1 and 7. It doesn't matter which point you select. Both of them would be correct. T times the slope, which is 3 and 3. We do the same thing here. We can say, because it's 3 space, we have x, y, z, 6, 2, 5 plus t times 9 minus 6, 3, 2 minus 2, 0, 8 minus 5, 3. That's going to be the vector. Now we need to find out, determine if each point P is on the line. xy equals to 3 and 1 plus t times negative 2 plus 5. We want to find out if negative 1 and 11 is on it. So we have negative 1, 3 minus 2t, 11 equals to 1 plus 5t. So it's going to be negative 4 equals to negative 2t. T will be 2. What about here? We have 11 minus 1, 10, 5t. So t is 2 as well. So the answer is yes, that's on the line. Next one. 9 equals to 3 minus 2t. Negative 15 equals to 1 plus 5t. We have 6 equals to negative 2t. And we have negative 16, 5t. T will be negative 3 in this case, and t will be negative 16 over 5. So that's no. Next one. Negative 9 and 21. 3 minus 2t. 21, 1 plus 5t. So 3 when it goes the other side, negative 12, negative 2t. T is 6. And here, 1 goes there, is 20, 5t. T is going to be 4. Since they are not the same, it means that, no, it is not on the line. Now in this example, it says write the parametric equation for each vector equation. So I can say x equals to 10 plus 13t, and y equals to 6 plus 1t, or just t. That's the parametric equation. Now for next one, we have vector equation in 3 space, and we need to write it in terms of parametric equation. X will be 3 plus 60, y equals to 0 minus 90, z equals to negative 1 plus t. Now in this example, it says write a vector equation for each line given the parametric equation. Now it's the other way around. The parametric equation is given, we need to write the vector equation. First one, I can say xy equals to 3, 9 plus t times 5, 7. And here we have xy negative 5 and 0 plus t times negative 6 and 11. Here we have 3 space, x, y, z equals to 1, negative 6 and 2 plus t, 4, 1 and negative 2. And here we have 7, negative t and 0. You can say x, y, z equals to 7, 0 and 0 plus t times 0, negative 1 and 0. Then write the scalar equation. We have x minus 1 over 2 equals to t, and y minus 1 equals to negative 3 equals to t. So we have x minus 1 over 2, y minus 1 over negative 3. So when you cross multiply, negative 3 times x minus 1 equals to 2 times y minus 1. So it's going to be negative 3x plus 3, 2y minus 2. So we take everything on the left hand side. We have negative 3x minus 2y plus 3 plus 2 equals to 0. It's going to be negative 3x minus 2y plus 5 equals to 0. That's the scalar equation. Next one. X plus 2 equals to t. Y minus 4 over 5 equals to t. So x plus 2 equals to y minus 4 over 5. When you cross multiply, it's going to be 5x plus 10 equals to y minus 4. So we have 5x minus y plus 14 equals to 0. That's the scalar equation. Now next one, it says given each scalar equation, write the vector equation and parametric equation. Here we have x plus 2y equals to 6. If x is 0, y will be 3. If y is 3, x would be 6. So we have 0 and 3, and we have 6 and 0. So we can find out the slope. 6 minus 0 is 6. 0 minus 3 is minus 3. That's the slope. So that will be x and y, that's the vector form. 0 and 3, we can choose any of these 2 points, plus t times 6 and negative 3. And if I want to write in terms of parametric form, I can say x equals to 6t, I don't write 0, y equals to 3 minus 3t. That's going to be the parametric equation. Next one, 5x minus 2y equals to 13. Again, I'm going to make, let's say, x equals to 1. Then we can say 5 minus 2y equals to 13. So negative 2y equals to 13 minus 5 is 8. So y is negative 4. So we have 1 and negative 4. Next one, if x is 3, we can have 5 times 3 minus 2y equals to 13. So negative 2y equals to 13 minus 15. Negative 2y equals to negative 2. So y will be 1. So we have 1 and negative 4, and the other point is 3 and 1. So the slope is going to be 3 minus 1 is 2. 1 minus negative 3 is going to be 5. So we have x and y, 1 and negative 4 plus t times 2 and 5. So the parametric form is going to be x equals to 1 plus 2t, y equals to negative 4 plus 5t. Again, instead of 1 and negative 4 here, I could use 3 and 1 because both points are valid. Here in this example, it says which points are on the line. 7, 0, and 2. We just sub it there. It's going to be 7 equals to 1 plus 2t. 0 equals to 3 minus t. And 2 equals to negative 7 plus 3t. For the first one, we can say t is 3. For the second one, t is 3. For the third one, t is 3 as well. So yes, it is on the line. Second one, 2, 1, and negative 3. So we sub it there. 2 equals to 1 plus 2t. 1 equals to 3 minus t. And then we have negative 3 equals to negative 7 plus 3t. So that will be 1 equals to 2t, which is going to be t equals to 1/2. Then we have negative 2 equals to negative t. T will be 2. And finally, 7 minus 3, 4. 4 equals to 3t. We can say t equals to 4 over 3. So they are not equal. So no, it is not on the line. Now in this example, it says, in each case determine if L1 and L2 are parallel, perpendicular, or neither. So L1, we have it in scalar form. So 4 and negative 6 is the normal vector to this line. And the slope of this line is 3 and 2. When you do the dot product, it's going to be 4 times 3 plus negative 6 and 2. That make it 0. It means that the normal vector to this line is perpendicular to this line. It means that L1 and L2 are parallel. Why? Because the normal, which is normal is perpendicular to L1, is perpendicular to L2. So that's why L1 and L2 are parallel. Next one. We have 1 and 9 as the normal to L1. And L2, the slope is 1 and 9. As you see here, the coefficient of t is 1. The coefficient of t here is 9. So 1 and 9. As you see here, the normal to L1 is parallel to the line L2. It means that L1 and L2 are perpendicular. So in this example, it says determine the vector equation of each line. A line which is parallel to the x-axis and through points 3 and -8. So we can say x and y equals to, it's going through 3 and -8 plus t times 1 and 0. And second one, it says perpendicular to 4x -3y equals to 17 and through points -2 and 4. So that's very simple as well. X and y. It says perpendicular to this line. The normal to this line is 4 and -3. It means that this line is going to be parallel to 4 and -3. And it's passing through -2 and 4 plus t times 4 and -3. Next one. Parallel to the z-axis and through points 1, 5, and 10. It's going to be x, y, z, 1, 5, 10, plus t times 0, 0, 1. Next one is going to be parallel to x, y, z equals to 3, 3, 0 plus t times 3 minus 5 minus 9 with x-intercepts of -10. So since it says, first of all, it's 3 space, so x, y, z. The x-intercept is -10. It means that it passed through -10, 0, and 0. Plus t times, since it's parallel to this one, is going to be -5 and -9. Next one, it says with the same x-intercept as xyz equals to 3, 0, 0 plus t times 4, -4, and 1. And the same z-intercept as xyz equals to 6, 3, -1 plus t times 3, 6, and -2. So here the x-intercept is 3, 0, 0. So the first one is going to be 3, 0, and 0. It says the same z-intercept as this one. It means that x is 0, y is 0. 0 equals to 6 plus 3t. And y is 0 as well. 3 plus 60. So here t will be -2. Here t will be, so that will be -2. And z equals to -3 plus -2 times -2. That will make it as 1. So that's going to be 0 and 0 and 1. So m slope is going to be 3, 0, 0 minus 0, 0, 1. That will make it 3, 0, and -1. That's the slope. So the vector form is going to be 0, 0, 1 plus t times 3, 0, and -1. That's the final answer.